Rohit, Joshi, and currently at Cloud Factory. And the goal of this presentation is not only to make parallel tests or tests faster, but also have an idea to build a consistent test environment and reduce the friction across different environments where we run the tests. Before that, as Sorosai already mentioned, I am also one of the co-founders of Developer Nepal, and actually I'm wearing this shirt for the very first time. So 3 years ago we built the website, printed these shirts, but I had to go abroad, and then I never got a chance to wear this shirt. I always wanted to wear this on a special occasion, and because today is a special day for me, my very first talk. And let's see, so we all love TDD, we all like to write tests, but also we want a fast feedback loop. That means, for example, if I do a feature within 15 minutes, but my test takes like 50 minutes or an hour to run, then it's frustrating, right? We've all been in that scenario where we have to wait for tests, and the friction, different kinds of friction with the test environment. So, for example, we've been in a scenario where our test gets passed in local machine, but it always fails in Jenkins or somewhere, right? And then we just sit there figuring out a way, what is missing in my local machine, what is there in Jenkins, and that creates this friction, and we discourages us from writing tests, right? So here the goal is to create a flexible and replicable environment. That is, if I'm running some tests in my local machine, I also want to run the same test in a similar kind of environment, whether it's Mac, Linux, or Jenkins box, or any kind of operating system. I want the environment to be same, so that if the test fails at some environment, I want it to fail in my local machine, and also I want them to be fast, right? I don't want to wait for 40 minutes just to run the test for sake of running the tests, right? So that's the goal. And some of the key points that we want to be able to do with this is we want our tests to be run in an isolated environment. By that, what I mean is I don't want a lot of dependencies between the projects, right? That gives us a lot of headache when we have multiple projects running different versions of dependencies, and then sometimes in our local machine, our one project depends on something, and then our another project depends on something, right? So it causes some conflicts, right? And also we want other things like databases. We want to be able to run parallel tests, but we want the database to be different for each test, so that it can be run in a pure isolated environment. We also want it to be developer friendly, because we don't want a lot of dependencies, a lot of extra libraries to be installed in a developer machine just for sake of running tests. And we want it to be reliable and consistent, and then very configurable. Like I want to run this set of tests in this amount of containers, or for this time I just want to run this specs, or for this time I want to run serial tests instead of parallel tests. So this all has to be configurable. And the last is it has to be runnable in our local machine as well as in our CI servers, right? So we want this system to be consistent. And it's not the first time that we are trying to solve this problem. So there were existing solutions like parallel test, there were virtual machines, and recently, as I mentioned, there is this thing called knapsack. Although I haven't tried knapsack, I've tried parallel test. There were some issues with that already, like interference between multiple runs. And this solution I'm proposing is I tried this 2 years ago. So there might have been some recent developments, or there might be some more easier tools than this. But this is my experience 2 years ago. This is what I did 2 years ago. So moving on, so this is Docker-based solution. So as we know, containers are lightweight process that run in isolated environments. So not only for development or not only for deploying purpose, we can use that thing for tests also, because we want exact same kind of environments when we run our tests, right? We don't want the test run to be to hamper anything that goes with our development flow, right? So it has to go with our development flow. So Docker. So yes, so these are basic features that Docker containers provide us. Replicable environments, that is, if I'm using the same image in my Mac, if I use the same image in Jenkins, it basically means that I'm running in the same environment, right? And then run-coded isolation, as I have already mentioned, consistent build environments across many builds, and yeah, to speed up tests, so taking advantage of containers, so we can fire up multiple containers to fire up multiple tests. Not only multiple tests, but also group of tests, right? For example, if my feature specs is taking too long, so what I can do is I can divide feature specs, so I can fire off 3 feature specs in 3 containers, and then the model and lib and API specs, which are usually faster, I can run that in a different container. So let's say if my total test run time is 40 minutes, and then if I utilize 4 containers, then ideally all the tests should run in 1/4 of that time, right? And then yes, and practically in my previous project, we were able to reduce the test run time for 50 minutes to around 10 to 12 minutes each time. So that was a win for me, and that's why I'm presenting here as a foolproof method of doing this. So tools, so we basically need the Docker itself, obviously, and then I've used Docker Compose, and then Docker registries for different kind of images for Ruby, Postgres, and other dependencies. So the basic concept here is that it's very simple. It's much more simpler than anyone would thought. So basically, we want to fire up just one DB container that can be used by multiple other containers, because we don't want to fire up multiple DB containers, right? But though we want to have different databases for different test runs, right? And basically, what we'll do is we'll fire up 4 containers that runs 4 group of tests in a host, right? Whether it's localhost or whether it's Jenkins, wherever. So this very simple concept of how this will work. And I'll quickly move forward to demo. The code sample is up at GitHub, and then this is not a full-fledged application. It's just a demo application I put up for this presentation. So there are just few tests, so more tests that I copied over from another repository. So the app doesn't make sense. Actually, it's just for demo purpose. So I'll do the demo first. This is basically a user interface for containers. So what I'm going to do is I'm going to make parallel sticks. So what it's going to do is, so we can see that it has fired up a bunch of containers here, right? And then we can see the logs, what it is doing in those containers. So we can see a bunch of stuff here. It's trying to run this particular spec in this container. It runs it. a bunch of other containers where bunch of specs are running on it, independent of each other, and there's just only one Postgres container running in the background. And then so we can see the logs of different containers. So this is log from one, this is log from another container, this is from another container, right? So 4 containers. So this means that we were running, and then it prints out the container. So we were running a bunch of specs on a bunch of containers, right? So so how this works, I'm going to go into a little bit detail on this one. So this is the main entry point of the parallel specs. So here, right, parallel specs are accessed. This is shell script, and so basically what happens is, so I have this parallel bash script. We can get it through apt-get install or also brew install, but what I've done is I have just copy pasted that shell script here in my bin folder, so that I don't have to install external dependencies whenever I take this project, right? So it starts from here. So basically what I'm doing is -j job 4. I want 4 parallel processes, and then I'm feeding in this parallel test.tsv. It's basically tabular format. So instead of CSV, I've used TSV, where I can define set of specs that I want to run. So I have feature specs that I want to run in one container. I want this spec to be run in one container, and so it's basically 4. So as per our requirement, we can have spec/lib, right? Also spec/API and other stuff, right? And so we are feeding in this data to this script, which is a Docker spec run, and so we get here. So what happens here is that since I have already worked with this, so I already know some gotchas that we run into this. So Docker Compose doesn't like same name for different containers, so we have to make sure that the container name on each run remains unique. So that's why this is a little hack to generate a unique container name. And basically what I'm doing is Docker Compose run, remove the container after it's done, and name, I'm just giving it a name, and then the actual spec runner is this one, shell script, and then I'm just feeding in each row, which is, for the first time, I'm gonna get spec/feature. So it goes here, spec runner, which comes here. So here is the tricky part. So this is where we create a new database for each run. So here what is happening is, in short, so we are creating a new database from the test database template. And then when we run rspec, we are feeding in the new database name, so that on each containers we're going to have a new database, right? And then after that we clean that database, because at the end of the run we don't want our database to be hanging around in that container, right? So you can see it's pretty straightforward. There's no magic here. It's just explanatory, pretty straightforward. And then I have some cleanup script to clean all the unused or dangling images and containers here. So pretty straightforward. So as you can see here, we can have, if we have a big project with a lot of specs, so we can just divide the specs, just updating this TSV file and just updating this. So if I have 5 rows, I can have just job 5, right? So pretty straightforward. It doesn't have any side effects. It just uses standard Docker image. So wherever I run it, I'm going to get the same results anywhere. Docker file, it's very simple. Just the standard Postgres Node.js stuff. I copy things, right? And then Docker Compose.yaml, it's the same thing. Like same kind of Docker Compose configuration that we use on our daily basis. So that is basically the demo of that, and then it's on GitHub, so you can clone it on your machine and just one command. So I have used make files, so all the commands are here on the make file, so that you don't have to remember everything. Just shoot make DB setup, make parallel specs, make specs. So you can also see at the same time that this is very developer friendly. So it doesn't rely heavily on the DevOps side of things, right? It's very programmatic. Questions already?